Okay, so tonight we are going to talk about section 6.5, rhombi and squares, and we're just going to get right into it. Okay, so remember from last time that we talked about rhombuses, or rhombi, squares, and rectangles are all types of parallelograms. So all of the rules we have learned about parallelograms are true for each of these three shapes as well. However, I want you to remember that since the last video we talked a lot about rectangles, do not make the mistake of thinking that everything that's true of rectangles is true of rhombi. That is not correct. Okay? Everything that is true of a rectangle is true of a square, but everything that is true of a rectangle is not necessarily true of a rhombus. So I just want to point that out and keep that in mind. Okay. The rhombus corollary kind of defines what a rhombus is. It is a quadrilateral that has four congruent sides. A quadrilateral is a rhombus if and only if it has four congruent sides. So if we know that this and this and this and this are all the same, then we know that we have a rhombus. Okay? So if AB is congruent, I'm going to kick out of full screen to get my magic pen back. So if we have AB is congruent to BC, is congruent to CD, is congruent to AD, okay, then we know that we must have a rhombus. Let's move along. I'm going to leave the next two questions for you to figure out. They should not take you too long. And then we talk about theorem 8.11. A parallelogram is a rhombus if and only if its diagonals are perpendicular. This is another fun fact about a rhombus, that if you have two diagonals, they will always meet at a right angle. Right? Which is very, very easy to understand. And so we will just quickly say that if ABCD is a rhombus, then AC is perpendicular to BD, and we'll try to do some math with it in a moment. But first, theorem 8.12. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. This one's a little tougher to understand, okay? But all that's saying is that if we have a rhombus, then each diagonal will cut the two angles that it touches, namely B and D, it will cut them in half. So B will be cut into two equal parts, but also D will be cut into two equal parts. Now these are the same. This right here is the same as this right here. And in fact, it's the same as that one, and it's the same as that one. And that's true because we know that angle B and angle D must be congruent to each other, because this is, in fact, a parallelogram as well. And you remember that in a parallelogram, opposite angles must be the same. So angle B and angle D must be the same. And the same thing goes for the other diagonal. The one AC will cut angle A into two equal parts, and it will cut angle C into two equal parts. Okay? So let's fill in our little cheat sheet here. If ABCD is a rhombus, then we know angle DAC is going to be congruent to angle BAC, is going to be congruent to angle BCA, is going to be congruent to angle DCA. Let's quickly point out what that actually is saying here. That's saying that if we have a rhombus, then this angle here is going to be the same as this angle here, is going to be the same as, let's see, BCA, this one right here, is going to be the same as this one right here. Okay? So these four. 1, 2, 3, 4. And clearly, with the next one, we're going to say that this, and this are all the same. Angle ADB is congruent to angle CDB, is congruent to ABD, is congruent to CBD. Sounds good? Let's see if we can do some math with this. EFGH is a rhombus. Find X, Y, and Z. On the next two pages, or on the next page, we will talk about how to do this. Okay? Okay. So I just paused the video for a moment, and we are back. So we've got all sides of a rhombus have to be congruent. So you know that EF is congruent, or it must equal HG. That is to say that this and this must be the same. So we've got 2x minus 10, or 2x minus 6 equals 10, and we can solve for x there, and we get that x equals 8. Okay? The same thing is, because all of the sides have to be congruent, not just opposite sides, we also know that 5y, that is EG, I apologize. I need to edit these things better because clearly the people I steal these from and modify them are idiots. EG must be the same as GH, okay? So I know that this side right here and this side right here must be the same. So 5y equals 10. You can solve for y easily. And then to find z, we have to figure out something to do with that. Okay? So we go down here and we know that because consecutive angles of because the consecutive angles of the parallelogram, because they are consecutive angles of a parallelogram, then the rhombus, I apologize. Let me try one more time. Okay? Because we have a parallelogram, we know that consecutive angles must be supplementary. So I would need, because this is a parallelogram, I know that this and this are supplementary. Or I know that this and this are supplementary. And I'm going to use that to know that 70, the 72, or angle E, angle E plus angle F have to equal 180. However, I also know that this is a rhombus, not just a parallelogram. So a rhombus tells me that this diagonal must bisect angle F. And so Z is going to be exactly half of angle F. So angle E plus 2Z, because 2 Z's together make up angle F, are going to equal 180. I know that angle E is 72 degrees, plus 2Z must equal 180 degrees, and I can easily solve from there. Okay? So I subtract 72 from both sides, minus 72, and I get that 2Z equals 18, or Z equals 9. And we found everything. We have found X, we have found Y, we have found Z. And okay, and then we need to did I make a mistake? Oh, I'm sorry. I made a big mistake there. I apologize. I'm trying to do this quickly. It's late. I'm making mistakes. 2Z is equal to 10. 2Z is equal to 108. And so Z is going to be equal to 54. Okay? Clearly 180 minus 72 is not 18. All right. And we are done. We have figured that out, and we are moving on. So let's try this one. The quadrilateral is a rhombus. Find X, Y, and Z. I think I might let you guys do that one. Along with that one. This is a very easy question. Don't try to overthink it. That one's a very easy question for you guys to do. That one is very similar to what we just did. Keep in mind that the rhombus is a parallelogram. So this and this are going to be supplementary. And that it is a rhombus, so this will bisect this angle here. Okay? So I really want you guys to be able to do this one. It might show up on some sort of CB or assessment. I don't know. This one is for you guys to do. and we are on to squares. The square corollary says that a quadrilateral is a square if and only if it is a rhombus and a rectangle. So as long as I know that my shape is both a rhombus and a rectangle, I can immediately say, hey, I've got a square. Okay? That means that a square has all the properties of a rectangle and a rhombus. Okay? So let's draw in all of the properties of our rectangle and our square. And I am going to cheat by just doing this. Okay, so we know that we have, because we have a rectangle, we know that we have 4 right angles. Okay, because we have a rhombus, we know that we have 4 congruent sides. Okay, because we have a parallelogram, we know that because we have a parallelogram, we know that the angles or the diagonals bisect each other. Okay, and because we have a rectangle, we know that they must in fact be equal. So we know that these are all going to be congruent. And finally, because we have a rhombus, again, we know that this must meet at a right angle, the 2 diagonals. Okay, so you might want to go back and watch that again, or as you're drawing it in, make sure that you understand how all of these things are true. But a square has all of these properties. Okay, so let's figure out what x, y, and z are in this picture. Okay, I know that, well, where do I want to start? If I edit this the way I want it to, I did. Okay, so we know that in a rhombus, the diagonal bisects the opposite angles. That is to say that this diagonal here will cut this angle and this angle in half. Okay? So I know that 5x must be half of 90. Why do I know that that's 90? Because, remember, in a rectangle, all angles measures are 90 degrees, and a square is a rectangle. Okay? Having slight difficulties with my smartboard, please bear with me. So this is always annoying in a video, but I'm going to do this. Okay, let's see if that fixes it. Okay, so in a rectangle, all angles measured are 90 degrees. So I know that this angle right here has to be 90 degrees, and so 5x must be half of it. So I know 5x must be 45 degrees, which makes x 9. Okay, so I found x. Now I want to find, I would do z next, but let's see what they do. Okay, no, they're going to do y. Okay, y is awfully easy too, because I know that because it's a rhombus, this must be a 90-degree angle. Okay, so 3y must equal 90, and so y must be 30. And finally, because I have a rectangle, I know that the diagonals are congruent to each other, and because I have a parallelogram, they bisect each other, so this and this must be the same. Z minus 4 equals 6, so z equals 10. Okay? I am done. The quadrilateral is a square. Find x, y, and z. So let's do one more. Let's see if I can move this over just a little bit first. Okay? And I am going to start with z because that looks the easiest. I know because this is a rhombus that the diagonals meet at a 90-degree angle. They're perpendicular, so 12z equals 90. Divide by 12. Divide by 12. And you should get, most of the time, 7.5. Okay. I also would have taken 45 over 6, which is also known as 15 over 2. Okay? So we've got z, and now we are going to try to get rid of this, shrink it a bunch. So that's z, and now let's work on the next one. I know that my diagonal pieces must be the same, so that must equal that in a square. Okay, so I know that 3y must equal 8y minus 10. So I subtract 3y from both sides, subtract 3y from both sides. 5y minus 10 equals 0. And I'll add 10 to both sides. 10 equals 5y. 5 by 5, 5 by 5, y equals 2. Okay, so now I've got y. And that leaves only x to deal with. Oops. Shrink this out of the way. Put it down here. Okay, and I know that this must be a 90-degree angle because I have a rectangle here. A square is a type of rectangle. And I know that the diagonal bisects it, okay, because this is also a rhombus, okay? So I know that x squared plus 9 must equal half, or 90 degrees, divided by 2. So x squared plus 9 must equal 45 degrees. From there, it's not too much of a challenge. Subtract 9 from both sides. We get that x squared equals 36. And so we take the square root of both sides. And I want to caution you not to make the mistake of saying it's 6. X is plus or minus 6. Now the only thing we have to do once we say that the answer is plus or minus 6 is check to make sure that none of these give us a negative answer. Okay? So the only place that we have x here is x squared plus 9. So whether we take a positive or a negative side of x, when we square it, we'll get a positive number. So we haven't broken any rules. Okay? We do get that x is positive or negative 6. Okay? And I am done with this one. The quadrilateral is a square. Find x. This one is for you. As is that one. That one. That one. Let's see, keep going. Okay. Let me just make sure I didn't skip any. No, I didn't. And here we're going to finish up with a nice summary of rhombi, rectangles, and squares. And I'm going to cheat by just doing the columns for rhombus and rectangle. Okay? Diagonals are congruent. The diagonals are congruent where? Well, I know that in a rectangle, the diagonals are congruent. That is not the case for a rhombus. Certainly not always. Okay? Diagonals bisect opposite angles. I know that that is true in a rhombus, but not necessarily in a rectangle. The diagonals are perpendicular. I know that that is true in a rhombus, but not necessarily in a rectangle. Has 4 right angles. I know is true of a rectangle, certainly not always of a rhombus. Has 4 congruent sides. It's certainly true of a rhombus, but usually not for a rectangle. And opposite sides are parallel. This is going to be true of a rectangle, certainly. But let's think about a rhombus. Is that true of a rhombus? rhombus kind of looks like that. And we know that it is a parallelogram. So opposite sides must be parallel there as well. Okay? I welcome you to go back to the theorems and the corollaries that we have dealt with and see why each of these are true. But notice what I have done is I haven't talked about squares at all, and that's because I am, as I mentioned, going to cheat here. I'm going to clone these and just pull them over because I know that every square is a rectangle. And then I am going to clone these because I know that every square is also a rhombus. So as long as I can fill in the two columns for rhombus and rectangle, I have my square by just combining them. Okay? And we are done with this lesson.